So we are going to start our first chapter with ASNT LT Level 3 Study Guide. So we are using latest edition. So this is the latest edition available in the market. So total it is having 6 chapters. It's a very simple study guide, but each and every chapter we explain with our PPTs. So the first one is nothing but introduction. So today we are going to cover some introductory information about leak testing, but this book not covered everything in detail. They ask you to refer to the handbook for more information, but whatever they given here, right? So we explain with our PPTs. So as you seen, right? So the first one, introduction, is related with the principles or theory. Some of the principles or theory part is covered with the chapter 1. So background. So the applications of leak testings are very diverse because they are used in many industries such as nuclear, aerospace, chemical, electronics, automotive, to name a few. So almost every industry they have a lot of applications with the leak testing. Even your food industry also, especially if you see the oil packets and all these things, so they sealed without any leakages. So you are receiving the packet, right? Electronics, electronic equipments like batteries, battery leakage, and chemical like tankers, chemical oil storage tanks, pressure testing, we do pressure testing, and insulation leakages. And aerospace industries are completely based on leak testing, especially if you see the your fuselage, the air cabin, everything is a pressurized. You need to maintain the required pressure because at a high altitudes there is a variation in the pressure, so they must be tested for leaks. And nuclear industry is completely based on this, like reactors and all these things. The radiation should not leak outside, and moreover the quality requirements is very high. So especially the R&D departments and nuclear departments, and some aerospace industries, so they will do a proper leak testing, and then after only they'll start their operations. And automotive industry, so like your tankers, chemical tanks, or your engines, motors. Okay, so this diversity complicates the subject because each field has its own applications, special techniques, and a special technical language. So when you applying it in nuclear industry, so they may talk with a different tone or different language. If you go oil and gas industry, we call it as a hydro testing, pressure testing, and other things. But when you go nuclear industry, they call as a hermetically seal or like leak proof systems. So they may use a different language or different techniques or different tracer gases, different equipment, different sensitivities. But at the end, the motto is they want to detect the leak sensitivity, meaning they want to detect the minimum leakage, the smallest liquid or smallest quantity of gas that is leaking need to be detected. So that's why even though equipment is different or techniques are slightly with the different languages and other things, but the basic concept is same. So they are all similar in basic principles. So that's why if your basics with the leak testing is strong, if any question comes in the examination, you can able to guess. Only the language only slightly twisting. So this review will emphasize helium, halogen, bubble, and pressure change leak testing methods. Just now we seen, right, totally that level 3 study guide or the level 3 syllabus is focused on the 4 methods. One is a bubble leak testing, and another one is a pressure change testing, and helium mass spectrometer leak detector, halogen leak detecting. So the 4 techniques, but you have many other techniques, but the industry mainly using these 3 4 techniques. So that's why in the exam also you can expect more questions from these. And compared with other NDT technique like RT, UT, MT, PT, so these are all tested on the raw materials. For example, if you are dealing with the ship industry, so you are taking the raw rolled steel plates, raw material. So before welding, you are checking for lamination, and before like start of the welding, so when you prepare the grooves, maybe the heat affected zones, you may do PT or MT. Then after welding, you are performing again RT or UT, right? So you are starting with the raw material, and up to end like a final product also you are checking with some NDT methods. But when it comes to leak testing, it is more frequently performed on a finished assembly to ensure the leak tightness as a finished products. Best example, your cylinders, pressure vessels, pipelines, or even before you do a commissioning, so all the CNG cylinders, LPG cylinders, right? Those are all need to be tested, leak tested, meaning once the component is ready, you fill with some gas medium, then you pressurize and test for the leakages. Even if you see the car tires, vehicle tires, so when you want to do a test for punctures, so you fill with air medium and dip into a soapy solution, then you can find out the leaks. So what they're trying to say here we are going only after the completion of final component or final fabrication. So the technique doesn't necessarily ensure structural integrity except to the extent atmospheric pressure exerts force. For example, your main intention is to check whether it is leaking or leak proof, or if it is leaking a small quantity, you can measure that and you can give the report. It doesn't mean like if you tested means it never fails. You see most of the like hydro testing or pressure testing, so the lines you are testing, but sometimes they are also leaking, they are also exploding. Even the gas cylinders all tested, but sometimes once in a blue moon there maybe the cylinder will leak. So that's why you need to be very careful. So when you are giving a report, you can tell about the leakage sensitivity details, or you can give a statement saying that we tested at that particular pressure and it is safe to operate, but we doesn't give any warranty. If that tank is leaking or if that particular cylinder is exploding, we are not responsible. So that's what here they're saying, there is no absolute leak proof system. So you can tell like the minimum leakage is this much, or at that particular point in time we are not able to detecting the significant leakage, but we never say the system is completely leak proof. Okay, one second. Okay, so the next one. So a broader tabulation of leak testing techniques in listed in table 1. You can see hundreds of techniques available, but they listed out main techniques. So you are very familiar with this bubble leak testing. You can see somewhere here air bubbles in water, air and soapy solution. You see the test sensitivity is a 10 power minus 4 to minus 5 Pascal per meter cube per second. PA is nothing but Pascal, it is unit for pressure. Meter cube is nothing but unit for volume, PV, and second. So if you combine P and V, this is nothing but we call it as a quantity. That is nothing but how much liquid is leaking. So that is what here PA meter cube is nothing but quantity. For example, I say 2 drops per second or 3 drops per second. So you can say it is a quantity leaking per second. So when you call it as with respect to time, that is what we call as a rate, hourly rate. How much? What is your charge for rate? Hourly basis. What is your overtime rate? $100 per hour, right? Here also 1 liter is leaking per 1 second. This is what we call as a leak rate. So how much quantity is leaking with respect to time? That is what we call it as a rate. And if you see here, they call it as a MDL, minimum detectable leakage rate, MDL, or minimum detectable leakage rate. So how much minimum you can able to see. For example, here you see 10 power minus 4, 10 power minus 4, but when you see mass spectrometer envelope test, so 10 power minus 11 means you can able to tell one drop is leaking per 10 years. So something like this, I'm just giving an idea. So that much sensitivity you can able to detect with mass spectrometry. You can able to say very small leakage levels. But when you see here air bubble like 10 drops or 10 bubbles coming per 1 second, so it is having a low sensitivity. But here one bubble is coming over a period of 10 years, so very high sensitivity. And even compared to this radioactive isotopes, also radiation leakage, like you can use a radioisotope and also you can perform leak testing, but that is slightly not like popular one, but mass spectrometer is a more popular one, especially if you are going for any nuclear or any special applications, reactors and other things. So those places they always recommend for this mass spectrometer. The problem is most of the technicians not properly qualified, and they just know how to operate the equipment. Based on that only they'll perform and give the report. Okay. And moreover, we used to get inquiries for this testing. People don't understand the importance of leak testing. and they used to tell like they need only 1 day training, and they used to pay only $100 $200 per technician, and just by paying $200 they need level 2 certificate. So these kind of scrap inquiries we used to receive more frequently, because the people, their mindset is adopted with this. They think like leak testing is nothing, it's everyone can do this one. That's the problem with the current industry, and most of them is not having a proper qualification, and they don't know how they are doing all these things. They just operate the equipment and they give some report. Okay, but some places like labs or nuclear facilities, or some places they engaged the laboratories, like they engage a specialized companies, so who are all performing the testing. They also associated with the manufacturers, so they will come and install their setups and all these things. They use a vacuum pumps, and they create a required vacuum and all these things, then they'll perform a proper test. That is a different. But when it comes to industrial environment, most of the places they don't use properly qualified technicians. Then why we need to do the leak testing? So to prevent the accidents, you can see here most of the places you may see explosions, implosions, leakages. You can see sometimes battery leakage. So EV vehicles, especially the electronic vehicles, because of the battery leakages, battery issues, so you may see some kind of explosions, and sometimes the tank, storage tank leakages. And you can see the aircraft also, they tested this one in 1988. So if your cabin pressure not meeting the requirement, sometimes these things happens, because outside pressure is different, cabin pressure is different. If it is not maintained as per regulations, so it may lead to accidents also. Then you can see industrial environment. So you may another best example, your house. Maybe 10-15 years ago, most of the houses used to leak because of not having that proper infrastructures, interiors and all these things. Especially the rainy season, we used to see all these things. And even your air conditioner, sometime in the summer, if the usage is more, sometimes they also start leaking, right? Another one is a data leakage. Every day you may see like spam calls or messages, the data leakages. So this one is a one such a case is a WikiLeaks. So he leaked all US government sensitive information. He leaked to the society. WikiLeaks. And the cyber security is also considered as one of the leak, because your sensitive information they are leaking, like bank passwords and all these things. So even small leakage also sometimes causes huge consequences, especially the gas leakages, flammable liquids, or flammable gases. If anyone nearby started smoking, it leads to explosions and increases the fatalities. The main problem is uh, it it impacts the entire company. For example, if someone working in oil and gas industry is smoking inside the plant, what happens if any gas leakage is another thing? So it catch fire and entire plant will explode. So also the owner losing assets and fatalities, and also government imposing fines and reputation in the market. So that's why sometimes you may think only 1 liter is leaking or 100 ml only leaking, small quantity. It doesn't mean about that quantity or the cost of that particular liquid. It always about the consequences, because of the fatalities, fines, and also the operational losses, like um, the period, like they need to close down the plant for a few days, so the production losses. So combinedly is a huge loss to the owner, and also assets. The assets also will get damaged, and they need to bring the spare parts. They need to do the repair. So many things get involved. That's why they used to invest a lot of money on these safety requirements, and they always ensure there is no such kind of leakages. So by installing the zone monitors, area monitors, gas detectors, so the timely collect all these leakages and they'll minimize. Okay, you can see here even small leakage also matters. Sometimes small leakage costs very huge amounts. So what are the main reasons? So to prevent loss of valuable material, here valuable means not that liquid. For example, you are dealing with the water. For example, in your house, maybe the tap water is leaking. So you may think the water is leaking, water is inexpensive. But the problem is like someone slipped on the bathroom floor. What happens? Medical expenses, especially the old people when they sleep on this wet floor, so it leads to huge medical bills and also sometimes fatalities also. So that's why it's not on the quantity, and sometimes it's maybe flammable gases, so it can catch fire, or it may be poisonous gases, chemicals, especially in the confined space or any live areas. Like if any gas suddenly leak, so people die on spot. In India, sometimes we used to see the news articles about sewage lines. When they open the sewage tank, so some chemicals they inhale and fell unconscious, right? And some people die on spot also because the poisonous gases. The next one is to prevent a hazardous condition or contamination, especially in food processing industry. So one chemical mixed with another chemical, so leads to some kind of poisonous combinations or maybe hazardous scenario. So hazardous condition or contamination, especially the chemical plants. So we should minimize the leakages. Otherwise, sometime maybe the steam is leaking and interacting with another nearby insulated item. Maybe you may see insulation damage, or maybe you may see that particular valve is getting damaged. So these are all like consequences associated with the leakages. Then to ensure proper assembly by detecting a missing or faulty component like a gas cylinders or any pressure vessels, so you can perform the test and you can see the missing items even when you go for a commissioning stage. So the entire pipe spools or any complete setup you want to hand over, you can do the pressure test. So if you see the pressure is not retaining, then you suspect something is faulty. Even your tire also same, the tire punches and all these things. So you pressurize, but after some time the pressure is reduced, so you feel the puncture is not done properly, or maybe there is another puncture. So likewise you can check with the leak testing. Most of the time industrial application we test all these items. So leak testing is frequently performed on a finished assembly. You see here, this is completely finished, then they tight the manhole everything and then they perform the test to ensure the leak tightness. So leak testing is most efficient and cost effective when performed in a proper way. So by using some sensitive techniques like a helium mass spectrometer, you can go up to 10 power minus 9 or 10 power minus 11. So very small leakages also you can able to detect. That is what we call as a leak test sensitivity, the ability to detect a smallish quantity of the liquid. And in no case we can say there is no like leak proof system, but instead of that we can say no detectable leakage. At that particular point of time we are unable to detect the leakage, or maybe the leakage rate is very small. So what is the meaning of leak? Leak is nothing but a hole or a void in the wall of an enclosure. So you are speaking something in your cabin, so that information leaked out because someone listening to it, or maybe there is a hole in the system, so you can, the data is leaked. So capable of passing liquid or gas from one side to another side, especially if you see the bubble leak testing. So you are pressurizing the tire with the air medium, so the air is leaking through the rubber tire. Suppose this is a hole, so your air is leaking, and if you apply a soapy solution you can see the bubble formation. So basically the gas is leaking from high pressure to low pressure. Leakage, as I told, right, it is nothing but a measurable quantity of fluid. How much leak, whether 100 ml or 1 liter, 5 liters, that quantity we call as a leakage. If you measure this quantity with respect to time, then we call it as a leakage rate. So quantity of leakage fluid for unit time, per hour how much is leaking. For example, in your kitchen maybe per hour 5 drops are leaking. That is what we call as a leakage rate. So if it is per hour 5 drops means you are ignoring. For example, per hour if 10 liters of water is leaking, then we will try to fix it immediately. So what we are trying to say here, sometime when the leakage rate is very small, you may not take any preventive measures, or you may monitor it. But if the leakage rate is very high, then you may take immediate precautions, or you may go for immediate shutdowns also. So how to detect this? So with the help of your instruments, a device for detecting, locating and measuring a combination of leakage, that is what we call as a leak detection technique. So you can use several equipments and you can detect it. One of our best leak detector is your nose, right? Your nose is considered as one of the leak detector. especially when we go inside a kitchen. So if the gas cylinder is leaking means immediately we smell it out. If any bad smell coming, so immediately our nose will alert us. That is what leaking. So leak testing categories, they categorize into three ways. First one is a leak measurement. So you can measure, especially the industrial area, we use these kind of sensitive equipments and we measure the leakage. So at the end in the report they will tell like the leakage is from something like 10 power minus 2 to 10 power minus 3 Pascal meter cube per second. Or if you're using a helium spectrometer, they may put like this 20 into 10 power minus 11 Pascal meter cube per second. So you may get a leakage right. Then leak location. So if it is a pipeline, so sometime you need to pinpoint where that is leaking, exactly where it is located. Especially you see the plumbers, so they will identify the leak location and they fix it. Then the third one is leak monitoring. For example, in your kitchen you feel the gas is leaking, but a very small amount of gas only leaking. So what you will do, you will monitor for a few days. Then after one fine day you plan for replacing the valve or regulator. You can see if the leakage is very small, then only the best option is you can monitor. If it is exceeding the limits, then only you can take corrective actions. Then leak measurement. So the total measurement of leakage. Leak testing is nothing but locating or measuring the leak or leakages. Leak monitoring is the same thing. So leak monitoring means it is a long-term process. Maybe you need to monitor for 5 days, 10 days, or 1 month, 1 year. That is what leakage monitoring. Especially in the offices like MNC companies, what they do, so they feel like someone is leaking the data to the competitors. So what they do, they'll monitor, they'll keep spies and they'll monitor for 1 year, 2 years. One fine day they catch the culprit. So that is what here like long term and continuous tests. Leak testing is nothing but you are locating or measuring leakage. So locate and fix the leak sites, and sometime if it is not in a condition to fix it, so you can try to minimize the leakage. So you can see here many techniques. So one of the highest sensitivity is a mass spectrometer, and you can see pressure change testing. This one is a bubble solution, is nothing but immersion, or you can apply a soapy solution. So each and every technique, the working mechanism is different, equipment is also different, the interpretation also different, the observations also different, and reporting also different requirements. Okay, for if you are dealing with a radioisotope, so what tracer gas we are using is a krypton. This is a radioactive material, krypton 85 we are using. Okay. Then coming to the leak testing techniques, so overall there are several techniques. So based on the working principle they call with a different name. So same whatever we seen in the table, right, the same name. Pressure change, even penetrant leak testing also is one of the leak testing technique. How we do this? For example, this is a small container or a small storage tank. So you want to see whether it is leaking or not. So what I do, I'll apply the liquid penetrant inside. This is a PT chemical penetrant I applied inside, and outside I'll apply the developer. So what happens if there is a hole, if there is a leakage, what happens? The penetrant slowly comes to the other surface, and here you can see the red color spots. So this is what we call as a penetrant leak testing. And laser imaging, hydrostatic pressure test, fill with water and pressurize and test. Halogen detector, chemical based, bubble leak testing, acoustic emission. These are all some of the popular techniques. Then coming to the safety, safety is very important with leak testing. That's why in the exam also they're asking 6-7 questions directly from the safety. So what is the danger involved? Danger of implosion or explosion. If it is a pressurized item, so you can call it as explosion, like a gas cylinders pressurized, so they explode. Even battery also like exploding, right? But what about implosion? Implosion is nothing but vacuum, like submarines and other things. So when when they got a issues with the vacuum, so they'll implode. Implosion is nothing but opposite to the explosion, exploded, and both are dangerous. So one is involving with the evacuated system, and this one is a pressurized system. So mainly leak testing is associated with the two categories. One is a vacuum and another one is a pressurized system. And the flammability of tracer gas, especially when you're dealing with a vacuum system. So we used to spray some gases, that is what we call as a tracer gases. Sometimes you may use flammable gases, or they used to be toxic in nature sometime, or sometime when they interact with other chemicals leads to explosive. So that's why the tracer gas flammability also important. Asphyxiation, some tracer gases easily replacing the oxygen. So you may not have enough oxygen levels, especially in the confined spaces and other critical locations. So you may get asphyxiation. Then next one is a poisoning. So some gases, when they react with other gases, may be becoming very poisonous chemical. So if inhale, maybe leads to fatalities. Then freezing, when you're dealing with cryogenic systems like liquid nitrogen or any like low temperature chemicals, if we touch, they immediately freeze. So that's why we need to be very careful when handling the leak testing techniques. So you can see here it is a liquid nitrogen freezing temperatures. Here it is explosion, so implosion kind of thing. So evacuating a system can create a substantial implosive forces. If you are dealing with evacuation, is nothing but implosion. If you are dealing with a pressurized system, nothing but explosion. Okay, evacuating, implosion, and the forces are implosive forces. Then you can see a pressurized system, nothing but explosive forces. So here you can see they given some example. Evacuated ball jars should be enclosed in a safety shields. For example, if you are doing these kind of evacuated system, you put a safety enclosure inside, you do the test. So sometimes you may see like this a test in progress, like they put a board and they put a barricade, they don't allow anyone inside this. So sometimes like aerospace structures or any like rockets or cylinders, some special items they will test in a remote locations. Even the bombs, nuclear bombs or some special kind of devices, they'll test in a remote areas. So they will even in the sea, also under sea or underground testings they'll perform. They ensure everyone is kept away from the testing area. The evacuated bell jar should be enclosed in a safety shield. Later you can see all these drawings clearly. Similarly, a pressurized system experiences explosive forces. Test pressure should not exceed the working pressure of a system and should be controlled by pressure regulators, pressure relief valves, and well-maintained calibration pressure gauges. You might have experience with a balloon. Best example, simple example is a balloon. So what we do, we blow air into the balloon, but we know that cannot withstand even more. But sometimes we give a try. What happens? Suddenly the balloon will burst. That is the one simplest example of explosion. So it is getting exploded. Even if your cycle tire, rubber tires, like a car tires, if you exceed beyond that working pressure, it leads to explosion. If higher test pressures are needed, so when you want to test at very high pressures, especially the thick walled vessels or high pressurized systems like 2000 psi, 3000, like very high pressures you want to test, means you need to have a special systems, right? Especially the compressed gas cylinders, LPG, high pressurized units. So you need to have a special systems. In some circumstances you may need to use a flammable gas as a tracer gas. So when you are using such gases, you must be very careful with the naked flames or any ventilation requirements. So you need to ensure the gases should not catch any fire. Okay, so that's why prevent the gas ignition, and you need to ensure a proper ventilation. And one such gas is a dangerous gas is hydrogen. Hydrogen gas is not recommended to use as a tracer gas. Why? Because it is very dangerous, especially when it interact with other gases, it leads to explosive nature. So it leads to explosions. So that's why, so before using this hydrogen, you need to purge your cylinders or your containers with nitrogen gas. So what nitrogen will do? Nitrogen will remove all the gases, residual gases inside the container, so that you can directly deal with the hydrogen tracer gas. Okay, you can make use of several gases. Sometimes we can use refrigerants, so R12, R22. So those are all used in air conditioner systems. So several gases we can use for tracer gases. So these are also for used as a tracer gas. They call as a refrigerants, more popular for leak testing. You can see here refrigerants. So they call it as a CFC, chlorofluorocarbons. So they interact with the ozone layer and they damage the ozone layer. You can see here chemical formula. So C stands for carbon. Cl is nothing but chlorine, and this one is a fluorine. So that's why chlorofluorocarbons. Chlorofluorocarbons, CFC, chlorofluorocarbons. Okay, trichloroethylene. Trichloroethylene. That most tracer gases are non-toxic, but they do present the hazard of asphyxiation, even though they are safe. For example, helium. Helium is non-toxic and lighter weight and more availability, but sometimes it may create asphyxiation also. So what they're trying to say here, so when you want to make use of tracer gases, so you need to ensure they are flame proof, meaning not flammable and non-toxic and less hazardous, and they should not replace the oxygen, meaning you need to have proper ventilation system and other things. So very important to verify that it is a properly assembled and will not leak large quantities of tracer gas, meaning when you want to test, right, for example you want to spray 5 milliliters of gas, for example. So you need to ensure your cylinder is having a proper regulators, proper control, so that you can remove or you can spray only 5 milliliters. Suppose if your cylinder is not of good quality or maybe the regulator is not working properly, sometime what happens, mistakenly you may release 1 liter. You need to release only 5 ml, but mistakenly you release 1 liter. So that is why what they're trying to say, before the start of the test you need to ensure all these things and minimize the gross leakage of the tracer gas. That's why what they do, they'll go for a gross leak test first. Best example, if you check with the repair shops, the cycle repair shop. So what this guy will do, he will not fill the air tightly into the tire. So he just fill little bit and immediately he will check for the gross leakages. You want to check the bigger one first. Suppose this is a tire, so here you have a big one and here you have a small puncture. So what this guy do, he will just fill the air and immediately he find out the bigger one. He will not fill completely, he just fill little bit of air, immediately he will find the gross one, then he will fix it, then after he will completely fill and then look for others. So that is what here also they're saying, it is recommended that a gross leak test to be performed before the actual test. So this is a rough test, you do it first and then after try to fix the small one. Area monitors and portable detectors also should be used. Suppose if it is a gas, so in the near area, if too much of gas leaking means immediately it will blow the horn. Especially if you see the radiographic testing, so we use the survey meters, bleepers. So when you go inside the container or inside that exposure area, so the bleeper starts giving the sound. Or even if you see the gas detectors also another best example. If inside the confined space you have too much of residual gases, so what happens when you go with the gas detector, that will produce audible alarm, right? Immediately you need to request the safety for purging with other gases or use a proper ventilation system. So halogenated hydrocarbons will stagnate in low areas and helium will collect in close high areas. Adequate ventilation must be provided to maintain oxygen at safe level. So what they trying to say is, based on your tracer gas, sometime you need to follow your procedure correctly and then you need to take some extra precautions so that you can get accurate readings of leakage rate. Otherwise sometime accumulation will take place and you may get wrong readings also. So care must be practiced, so you need to use a face shields or loose fitting gloves. So we understood very clearly during the COVID time. You see, most of us, every one of us use the mask, use the gloves, are restricted to going outside like hospitals and other places. Right? Most of the places they use the face shield. Even the aircrafts also they distributed the face shields and gloves, masks, tissue papers. Right? So then hand wash, the what is the sanitizers. So here also you need to have such kind of attitude when handling some chemicals. You see here liquid nitrogen is very dangerous, easily can leads to freezing. Then cryogenic temperature of liquid nitrogen can cause instant freezing because minus 200 is very low temperature. So we should not touch with bare hands. We need to use a special aprons or special gloves. The tests that involve the large pressurized equipment may require special facilities or buildings that can shield personnel from hazards. Same like how we are doing RT. So here also same thing. We need to use a special containers or special infrastructure so that they will test in that area. Especially you imagine the explosive materials, explosions, explosive materials or special special instruments, or if you see the space industry, so they'll do the tests in the remote areas, so they'll ensure everyone is away from that area and they'll conduct the tests, experiments. Safety training is always very important and must be incorporated into the special training. But what is happening in the industry, so the technicians is less qualified, less educated, they use a cheaper labor to perform these kind of leak testing. And moreover, the safety person also don't know about all the safety aspects of the leak testing, and the level 3 also don't know anything about leak testing, how exactly it works, what are the safety issues involved, but they used to perform and they'll give the report. An attitude of top priority for safety is extremely important. Same like as I told, right, during the COVID time, how people responded to their own personal safety, the same kind of thing you need to apply here everywhere, whether it is a small leakage test, a small technique or big technique, or whether it is a less hazardable or more hazardous, so you still need to follow the safety aspects. You can see here hydro test. So most of the time what they do, they will do it in a remote area so that they can prevent the losses. Okay. Yeah, so this is about first chapter, introduction from level 3 study guide.